In this section, we will describe functions that are commonly used in the shipbuilding industry. Most of the features have been developed at customer request and are still being updated. I'm sure these functions will help you a lot in your work. It is a function to do automatically grouping by each working cross-section for multiple sections, elevation, plan, and shell that make up the shipbuilding model. You can automatically create groups based on coordinates or map file and set the numbering. You can create groups for all models or for only selected parts. You can display group tree on screen using Control key plus alphabet G key. When the main area option enables, the cross-sections with an area less than the input values will be created in the group with the name of etc. This is to prevent too many groups from being created. By selecting manual option, you can create a group by finding elements in a plane based on the direction and coordinates selected. It updates group names and folders automatically. It also automatically recognizes the model's outshell and groups it. You can automatically create compartment groups. Note that since the compartment command is run by recognizing the volume of the closed structure, all closed structures will be recognized as compartments if there are no holes in the model. Find Inside Attached option is the function that finds inside part of a compartment. Using min box volume, you can create compartment groups that exclude groups smaller than that. As a report automation function for shipbuilding model, Repost report is generated for element group. You can save the report template file in Display option. You can generate the report about the thickness, the corrosion, the material by each group using the summary report. The figure number, stress component, group name is automatically entered. When the auto view is selected, the stored view set in the group is applied first. You can use the contour report commands to generate a report by selecting the result case result type to output for each group. You can report the results of all result cases, result types for all groups at once. The contents on the screen are useful modeling tool lists for the shipbuilding industry developed by the customer's needs. I will explain in detail one by one. The TR3D command is a function for converting 2D geometry in a plane into 3D space. The origin point is the point on which the movement is based, and target 3D space is the plane in which the selected geometry will be placed. Finally, the X, Y, Z encode input values are the coordinates in which the origin point will be finally placed. This is a feature to align the node using the reference node location. First node is the reference node. You can move selected nodes using the reference node locations. If you want to change the first node, click the Control key plus the alphabet B key to change the first node. At the same time of node movement, when the connected shell element shape changes from rectangle to triangle or straight line type, it is a function to change automatically to appropriate element type or to delete. If moving node without using this function, it will be able to carry out the same automatic shape change task with Merge Coincident Node feature. The Find Mesh command is a feature that automatically splits the selected area into smaller elements. It's a powerful feature that can deliver very fast and high-quality results. This is a useful feature for partial detail modeling. You cannot get this kind of mesh result with general mesh function. Pressure applied to existing shell elements is maintained even after the fine mesh is generated. Users can use 3 methods to split elements. The fine method is used to perform fine mesh without creating a transition area. The both method creates the area of fine mesh and transition mesh. The transition method creates a mesh transition area considering the surrounding connected elements. The advanced break command is a feature that automatically splits adjacent elements using the node of adjacent elements present on shell element edge. When the Auto Select Edge option is enabled, it automatically recognizes nodes located on the edge without directly selecting element edge. It cuts also 1D elements together such as bar beam that are located on the edge line. By using beam to shell command, you can convert 1D bar beam elements to 2D shell elements. The command is supported only for TT1, T2, L-shaped beam. The physical property of the generated shell elements is automatically created and assigned by using the dimensions of the target beam elements. With Fasten Shell Ends option, you can generate automatically rigid elements at the shell both ends. Without the use of beam elements, users can create snip stiffener using line by 2 points and along edge lines. You can create stiffener elements by entering information such as the height of the stiffener, toe length, snipped angle, and mesh size. The opening mesh allows you automatically to create an ellipse, manhole circle, and rectangular holes. You can create up to 5 edge layers of the hole and automatically create 1D beam on the edge. COBR commands are functions that automatically generate the corner bracket. You can create a bracket by entering the length of both sides of the bracket or by selecting nodes of both ends. If both sides are the same length, they are created in a circle radius. If they are different, they are created in an elliptical radius. The double R command is a feature that uses 3 points to create a double radius corner bracket. The shape and input data are as shown on the screen. This feature creates a connecting area for the longitudinal reinforcement web frame for FEGate assessment. Currently, 8 types of connections are supported, and each type can store dimensions in advance using the preset function. This feature creates the end connection of top stiffener. Currently, 12 types of connections are supported. Mooring fittings command is a function that creates a FE model of chock and bollard using the entered dimensions. Each type can store dimensions in advance using the preset function. Using Show Drawing option, you can see a drawing of each type on the screen. The figure shows that the Panama chock and bollard models were actually created using the mooring fittings command. Lug modeling command is a function that creates a lifting lug using the entered dimensions. Each type can store dimensions in advance using the preset function. The geometry library command is a function that creates a frequently used bracket geometry surface. You can use the Create Mesh option to create the finite element model immediately. You can use the preset feature to save dimensions in advance. The Stool Builder command is a function that automatically creates the stool structure surface used in the offshore. It supports single, double type. The Pipe Modeler command is a feature that automatically models the pipe connection geometry. The user creates geometry by entering a location and radius. 1 main pipe and 1 to 3 connecting pipes can be modeled, and a mesh can be created immediately after geometry is written. After creating a mesh, you can get a good mesh result by modifying the connection part using the remesh function. Importer command allows you to convert XML files created by Veva Marine into Nastran PDF files. You can simplify the model using a cleanup option when importing.
For models, you can import material and physical property information from XML file.
This section is Property Tool for the shipbuilding industry. We will study the function of element corrosion, converting beam property, and mass tuning. The user can store corrosion data in the selected element. Element corrosion saves only corrosion information in elements.
The Change Corrosion Type function is used to convert or export element corrosion, ECR, to property corrosion, PCR. When ECR is converted to PCR, the element with corrosion information is automatically separated from the origin property. You must convert ECR to PCR or export the model in order to apply the corrosion margin actually in the model.
The method for defining corrosion value for the selected entity is with by constant, ratio, group element. By group list method defines the corrosion value for the group by entering the group name and corrosion value format in the text file. The by element list is the method that after comparing the base model and corrosion model, the difference will be applied to the base model by metadata. When you enable the corrosion addition plot option, you can see the corrosion margin applied in real time as the contour. You can check the properties applied corrosion margin by contour plot. You can modify or remove corrosion value applied to selected elements. When exporting models with corrosion value, you can apply the factor to the entire model or local factor to the selected element. Convert beam property command is a function to convert or extract the bar beam property in various ways.
The option Converting General Beam to Library Beam is a function to convert to the most similar beam, library, by using area, IZZ, IYY values of general beam property.
It compares existing libraries first, then finds equivalent bar, ROD, tube,
T, L beams using area and inertia values.
Caution: existing library comparison is very fast, but finding equivalent is slow. It is recommended that all used library properties be prepared in advance.
Change Property Type option converts PBR to PBAM property or vice versa.
It is important to note that not all of the properties will be converted.
Center location is geometry center for PBR and shear center for beam.
If these two center is different conversion, move section location also. When converting a bar to a beam property, there is no loss of information. However, when converting a beam to a bar property, information such as shear warping related values may be lost.
L-type P-beam L property cannot be converted to P-bar L format.
The beam lumping option is a feature that combines multiple beam properties with area and inertial moment to implement them as one property. The Add Lump Thickness option uses a method of increasing the thickness of the base plate without merging or modeling beams.
The option to convert overlap beams to a one-rod element is to change the overlaid 1D element to a single row type element in girder size modeling.
The welding point property command automatically searches for a joint part consisting of elements smaller than the mesh size entered and creates separate physical and physical properties for that part. You can use the mass tuning command to tune the member's mass by user-defined interval or element group. You can also adjust the center of gravity center of rotation of the model. Set actual mass as target command updates the target mass value to the actual mass value of the currently specified section or group. Tuning is carried out using material density and non-structural mass. Using the section information entered in the table, the weight of each member is tuned to the desired value. Mass tuning by group command tunes each group's mass for the group selected in the list. Undo all mistuned results returns all mass tuning tasks to their original state.
The COG and G-radius commands allow you to tune the center of gravity and rotation of the model to the desired values.
Tuning block setup sets the blocks to be divided for mass tuning.
COG and G-radius command tunes center of gravity, center of rotation to the target value.
During the tuning operation, new material physical property is newly created and divided. Tuning block setup sets the block to be divided for mass tuning.
After you perform mass tuning with the section option for the length of the ship and divide Y/Z direction of the model into 16 blocks or 36 blocks in total through the tuning block to run the COG
inertia radius of the model. Guide message is output when inputting an unimplementable value. This section is model check tool for the shipbuilding industry. We will learn about section property features except for duplicate functions in other sections.
This is a function to calculate section modulus, including shell and 1D elements.
It is calculated for the longitudinal member. In other words, it is calculated for the cutting plane. And it also calculates the increased thickness by the slant.
The figure shows an example of a calculation of a 1D element cross-section modulus.
Differences between offset values have been compared. If offset is not considered,
the moment of inertia in the geometrical center and 2D section origin can be confirmed to be the same.
This menu is related to analysis tasks for the shipbuilding industry.
Please refer to the technical note for buckling analysis and LRSDA manual for SDA loading engine.
Submodel analysis is an analysis technique that interprets local detailed models using the analysis results of the entire model. You can automatically assign load cases and analytical displacement of the entire model to the load boundary conditions of the local model has been implemented. The pressure location option determines whether pressure entering the uniform or variable type. Please refer to the workshop submodel analysis for details on how to use it. The buckling analysis function supports 3 methods based on the rules as shown below. Lloyd Buckle 2, and common structural rules for bulk carriers and oil tankers. You can automatically create the panel or manually a panel using elements selected by the users. Please refer to the technical note buckling analysis for details on how to use it. The frame plot command supports entering or importing the frame data of a ship directly into the table.
You can use the LRSDA setting value as frame data